There we go. Hang on. Let me know if you guys can hear me now. So, this is my very first live stream. I have streamed in the past on Twitch, but that's usually just playing video games like League of Legends, chess, all of that type of stuff. However, this is the first time I am doing a live math class. So, we'll see how it all goes. It's a fun little experiment. I think I'll be able to give you guys a really good class. At least I hope so. So, what we're going to go over today is algebraic expressions and variables. The very first things that I want to talk about are what is a variable. We need to set our definitions. And a variable is a letter used to represent a number. An expression, to define an expression, that it has numbers and variables, sometimes connected by an operation sign. So let's just take a look at what I'm talking about here. You might have seen variables before. So typically in the regular math world, they will have variables such as x, y, and z. But in your GED types of classes, they like to use everything from A to Z, and even smiley faces can be used, right? What a variable is just a placeholder. It's just holding the place for something else. Think of it like you are holding the line for somebody. So the variable is the thing that's holding the line. So variable, a letter used to represent a number. So it's holding the place for that number. All right. Let's take a look at our first question. I'm going to type that up, and that is going to be Gabe's current age is 3 times his sister's current age. Okay. If X is his sister's current age, write an expression that represents Gabe's current age. So this is going to be our first question. It's very similar. You'll find these types of questions on the GED, where it's a lot of math word problems. That's everybody's favorite thing is math word problems, and I'm going to try to help you better understand math word problems, right? So it says Gabe's current age is 3 times his sister's age. So how do we represent that? So the way that we represent that is we want to write down that 3. We want to keep the 3, right? That is important. So we're going to go 3 and then times multiplication. Well, when you need a variable, you can just place the variable right next to the letter, and that is the same thing as multiplication. So 3x. So when I write 3x, that is the same thing as 3. So same as 3 times a number. And remember that this variable, this x, is our variable. That is a placeholder. That is a placeholder for another number. So Gabe's current age is 3 times his sister's current age. If x is his sister's current age, write an expression that represents Gabe's current age. 3x, same as 3 times a number. Now we can put this into use. That's the powerful tool with algebraic equations, variables, all of this stuff. They are all tools for you to use to figure out, to answer questions. So let's just say that Gabe is 12. So what if, let me type this out. So what if Gabe is 12 years old? That's what we're going to answer. So what if Gabe is 12 years old? Well, we can figure that out with this expression. We're going to turn it into an equation, but we can write 3x equals 12. With 3x equaling 12, what we can do... Oh, looks like I have somebody in the chat. Welcome. I appreciate you watching. So what if Gabe is 12 years old? Well, we can... you have 3 times x, right? So 3 times that variable. We want to get rid of that 3, so our end statement just says x equals something. How do we get rid of 3 times x? Well, you do the opposite of whatever operation it is, right? So 3, oops. So what's the opposite of 3 times? What's the opposite of 3 being multiplied by a number? Well, think about your order of operations. So 3 divided by, so division is the opposite of multiplication. So 3 divided by this, so... All right, so 3 divided by, or 3x divided by 3. And then whatever you do to one side of the equal sign, you must do to the other side of the equal sign. So 3x divided by 3 equals 12 divided by 3. And then what happens? What is 3 divided by 3? It's an easy question. Don't freak out about it. So 3 divided by 3, well, that cancels itself out. That is the same thing as 1. It disappears for all that we care about. And what is 12 divided by 3? Well, let's get rid of the 12 divided by 3, and that equals 4. So our answer then, so what if Gabe is 12 years old? Then his sister is 4 years old. That's where your algebraic expressions and your algebraic equations come in handy. They become very, very useful. All right. Let's take a look at another problem. And mind you, this is still algebraic expressions and variables. But this time, what we're going to do is we're going to draw out a rectangle. Oops. All right. There we have our rectangle. We'll make it a little bit more colorful. And what we can do is we can type this out. So this bottom length here is going to be 2w. Let's make this black. So 2w minus 3. And then on this side, we just have w. A lot of letters, I know. Don't freak out. Algebra has a ton of letters. It is very, very useful. Remember, variables are placeholders. So in algebra, all of the letters that you have can be used. It can be utilized. You can put numbers into them. So here we have, we're telling you that this length down here, the bottom side is 2w minus 3. And then this side over here, the short side of the rectangle is just w. Okay. Now, what our question is which, so we want to know what the perimeter of this problem, so if you don't know, the perimeter is when you add all of the sides together. So let's just type that question out. So what is the perimeter? So perimeter of this rectangle. So what is the perimeter of this rectangle? How are we going to write this out? Well, just start small. Take one thing a bite at a time, and you'll be able to get this, I promise. So let's go ahead and write out this first side. So remember, perimeter, adding, it's as if you're walking around the outside. Okay? So you're walking around the outside of this rectangle, and that is this. We'll just start right here, and we're gonna walk around. Okay. So this is our first piece of the problem. So 2w minus 3. And then we want to keep walking around. Hello, hello. I appreciate all of you watching. I hope that this comes in handy for all of you. I hope you can use my math classes and it will improve your math skills. I'm not going to do just math classes though. This is going to be GED, the whole thing, right? So I used to teach math, science, and social studies as an instructor at an adult learning center. I no longer do that. So 2w minus 3. So now we have to add this side in. So that is plus w. And what is this part right here? What is this? Well, it's the same thing as this one. So let's go ahead and add that in. 2w minus 3. And then we're going to go around. And now we've finished going around. So this is the plus w. We have it all written out. This is the perimeter. But we need to simplify the expression. We have to simplify it. We want to get rid of or make it as easy to read as possible. That's what simplifying really is you want to make it easy to understand. This is not easy to understand. So we have 2w minus 3 plus w plus 2w minus 3 plus w. That sounds terrible. That sounds absolutely horrible. So let's make it nicer. Well, first off, start with the variables, things with variables. So we have a 2w plus a w plus a 2w plus a w. Well, that equals, so 2w plus w is 3w, plus another 2w is 5w, plus one more w is 6w. And then we have a minus 3 and a minus 3. So what is a minus 3 minus 3? Well, that is a minus 6. So when we write this out, we get 6w minus 6. But that is still not completely simplified. We still have one more thing to do, and that is that we can actually factor out, we can take out, don't worry if you don't know what factoring is, but we can take out a 6 from this, because there's a 6 in this part of the expression and a 6 in this part of the expression. Think of it like we're just extracting it and setting it off to the side. Oops. So 6, and then I'm going to put a parentheses, w minus, so what is 6 divided by 6? Well, it's 1. That's why we have our imaginary 1 there, but we need a real 1 here. So our final answer for this problem is 6. Oops. Oh, geez. It got away from me. It's 6, and then w minus 1. There. So that is our final answer for what is the perimeter of this rectangle. Okay. Now, what if we have another question about this rectangle? Oh. Let me type that out. All right, so what is, oh, not in red. We don't want to go with red. What is the area of the rectangle? So we want to write an equation that represents the area of the rectangle. Well, under any normal circumstances, which this is normal, it's just that we have a lot of letters. But area for the rectangle, the equation for that is, so area equals length times width. Okay, so length times width. But we have expressions for our sides. So all we have to do is, I'm going to put them in parentheses just to keep them separate for now, and then I'll rewrite it. 2w minus 3 times w equals the area. Another way is writing it like this. So w and then 2w minus 3. That equals the area. And we want to do something very kind of special in algebra. This is why it's so powerful to use your variables, and why equations can be so powerful. So this w, this is being multiplied by everything inside of this parentheses. So all of the junk inside of the parentheses has to be multiplied by w. I just want you to think about what I said there. And now I'm going to draw it. So I want you to visualize, or you can look at this and kind of visualize what's happening. So this w is being multiplied by everything inside of here. So how can I rewrite this? But with multiplying the w through the parentheses. Well, what's w times 2w? Well, it is 2w squared. W times w, w squared. X times x, x squared. Z times z, z squared. 3 times 3, oh, you might think 9, but another way of writing that is 3 squared, okay? So 2w squared minus, and then w times 3. Always put your coefficient, always put your number in the lead, right? Like what we've done throughout all of this. So it is 3w, and that equals the area. And yet again, I want to do another example of how this can be used. So what if w equals 1? Yeah. So this is another way of just writing. What if w is 1? I have that question mark above the equal sign. So let's go ahead and put in 1 for our w. Remember, they're placeholders for numbers. So 2 and 1 squared minus 3 times 1. Well, what is 1 squared? What is 1 times 1? It's just 1. So 2 times 1 is 2 minus 3. So here, this is kind of interesting because this is area. So this is what we should get. We should get 2 minus 3, and that equals -1. But we're talking about area here. So it's impossible for us to have a negative area. So we'll just write this for now, and I'll do a lesson on this later, but there is an operation that we can do, or that we should have done, where it's impossible for us to get a negative number. But the answer, the area, equals 1. Okay? Let's do a couple more examples with different numbers here. So we're gonna keep the equation of 2w squared minus 3w, and we're gonna delete everything else here. All right. What if? So now let's do another one. Let's do what if our w is equal to 2. Oops, that should be a question mark. Oh, there we go. Got rid of it. Let's put a question mark. What if w is 2? Well, let's plug it in. So 2 and 2 squared minus 3 with a 2 there. And we just slowly work our way through the problem. Don't bite off more than what you can chew. Okay? So do your parentheses and your exponent first. So what is 2 squared? What is 2 times 2? Well, that is 4. So 2 times 4 minus 3 times 2. So 2 times 4 is 8. Minus 3 times 2, that is 6. So our area, when W is 2, so I can even just say that when W equals 2, area is 2. Kind of neat, kind of powerful, right? All right. Let's move on to another question. It's going to be another word problem, another math word problem. So I'm going to delete all of this stuff. And I'm going to go ahead and I'm going to write this out. So the width of Kevin's yard. Let's make Kevin a name. Kevin's yard is 10 feet more than twice the width of his garage. Write an expression that describes the width of his yard if G represents the width of the garage. Not too bad. I know it sounds horrible, but I promise you it's not too bad if you just go slow through this. So, and that's what I'm here for. I'm here to help you out. I'm here to help you through these things. So let's kind of take a second and I digest it. The width of Kevin's yard is 10 feet more than twice the width of his garage. So I want you to think of, what does 10 feet more mean? Well, that's plus 10. So we know there's going to be a plus 10 involved in this. So let's just highlight, let's just go through this and we'll go through different colors. We'll use different colors. Okay. So this 10 feet more. So that means that is plus 10. And then twice the width. So what does that mean? It's 2 times a number. And what is it 2 times of? Well, it is 2 times his garage. So if G is his garage, and twice the width, so that's 2 times. And remember, we can just write it as this. The 2 right next to the G that's in front of it, that means the same thing as multiplying. So it's 2 being multiplied, or G being multiplied by 2. And then the plus 10 comes in. So plus 10. All right. So let's just think about the width of somebody's garage. So what if somebody's garage, what if you are really lucky and you have a garage that is 20 feet wide, double, almost you could almost fit 3 vehicles in there, right? You most likely could. But let's just say, what if the garage's width is 20 feet? So what if, oh, it's in purple still. So what if the garage is 20 feet wide? Well, we can go ahead and figure out how wide his yard is. We can figure out how big his yard is based off of this word problem, this expression. They're tools to be used. So let's go ahead and write this out. So 2G plus 10 is our expression. So 2G plus 10. All right. And then we're going to plug in. So it's what if G is equal to 20? So what if his garage is equal to 20? How wide is his yard? Well, let's just plug it in. So it's 2 times 20 plus 10. And what does this equal? Well, 2 times 20 is 40 plus 10 equals 50. And that is feet. So Kevin's yard is 50 feet wide if his garage is 20 feet wide. That's pretty nice, right? That's pretty straightforward. It's not too crazy. All right. Well, so that actually is going to end my first not my class. I'm not ending it quite yet, but that's going to end the algebraic expressions and variables. And we're going to move on just to equations. So let's just go ahead and write up the definition of an equation. All right, so let's just delete. And what is the definition of an equation? All right, so the definition of an equation, it is a mathematical statement that shows an algebraic expression on each side of an equal sign. That right there is the biggest difference between an algebraic expression and an algebraic equation, is that you have that equal sign. For the most part, if you don't have an equal sign, then you just have an expression. If you have an equal sign and stuff before and stuff after it, then you have an equation. Okay, so equation, a mathematical statement that shows an algebraic expression on each side of an equal sign. Now let's take a look. Let's just see what these things are. How can we use them? So let's take a look at another word problem because it's everybody's favorite. So let me make this a little bit bigger. Levi paid 2 bills. The cost of the 2 bills was $157. The second bill was $5 more than twice the amount of the first bill. What is an equation that can be used to find the amount of the first bill? Okay, so perfect. We have our gross word problem. And like I said, you have to just kind of take a second and breathe. You have to analyze what is actually happening in this problem. So we're going to break it down piece by piece. Try to forget about all of the crazy mumbo jumbo that I said there. Try to forget about all of the craziness of this. And we're going to go sentence by sentence, piece by piece. Levi paid 2 bills. The cost of those 2 bills was $157. So let's go ahead and we're going to just write out that part. So something equals, the cost of 2 bills equals $157. 157. The second bill was $5 more. So that, I'll do this again. So $5 more. So that is plus, when you're $5 more, that means that you are plus $5, right? I'm giving you $5 more, so that means that you are plus $5 ahead. You've gotten extra money. All right. Then twice the amount of the first bill. So the first bill, we don't know what the first bill is, so we're going to say that this first bill, we're going to just say that is X. And then this twice the amount, that is multiply by 2. By 2, right? Twice means multiply by 2. So the second bill was $5 more than twice the amount of the first bill. So $5 more, so plus 5, $5 more than 2 times the second bill. So 2 times the second bill. So 2 is being multiplied by the x is being multiplied by the 2, plus $5 more, and that equals 157. So technically we could figure this out. Let's go ahead and just solve. Let's figure out what the first bill costs. The way that we can do that, this is called a two-step equation. So we have to do 2 steps. All right, so when you're solving an equation, it's all about doing your order of operations, but kind of backwards. So you really want to know your PEMDAS, right? I'm just going to put that up on the screen. PEMDAS, so PEMDAS. You want to know your PEMDAS. But in this case, let's just think of it as like kind of backwards. We want to think of starting with the easiest thing. So 2x plus 5, well, this plus 5 is farthest away from the variable. We want to get rid of everything around the variable. So we're going to subtract 5. Well, if I subtracted 5, if I took away 5 from one side, what must happen? We must remove 5 from the other side. That is the rule with equal sign. Whatever happens to one side must happen to the other. All right, let's rewrite this. So this cancels out. And 157 changes into 152 equals 152 2x, because this is just a plus 0, it just goes away. So 2x equals $1 or $152. And now, how do we get rid of the multiplication of 2? What's the opposite of the multiplication of 2? Yep, it is division by 2. So we must divide this side by 2 to get rid of the 2. Well, whatever we do to one side, we must do to the other. So let's divide by 2. This cancels out. 2 divided by 2 just turns into a 1. And what is 152 divided by 2? So let's just think here. 152 divided by 2. That sounds a lot like 76. So x equals 76. And that is in dollars. Don't ever forget your units. So $176. That's not too bad. That's not too bad of a problem, right? I know, and if you write notes and you take notes down as I'm doing this, you're going to understand it a lot better, I promise you. So it's not too bad. Let's take a look at another problem. All right, delete. And the sum of 2 consecutive integers is 15. Find an equation you can use to find the first number. All right, so this one is a little bit more tricky. The wording is difficult. So, 2 consecutive integers. What does that mean by being consecutive? Well, it's like 2 and 3, 4 and 5, 6 and 7, 13 and 14, right? So it's consecutive. They're one right after another. Let's write that down. So one after another for consecutive. So one after another. There we go. So that is what consecutive integers are. So example, that is like 4, 5. Another example would be 12, 13. They're consecutive, okay? Now it is 2 times, the sum of two consecutive integers is 15. So how do we write this out? Well, it is x minus 1, or x plus 1, sorry. So x plus 1. So if we have x plus 1, that is like the next one. That is the next number, right? So if I just say x is 2, then we plug that in. That is 2 plus 1, that equals 3. So that is the consecutive integer, right? So that is the equation that represents the consecutive integer. So x plus 1 is the second integer, and then it is the sum. So this is the second integer. What would the first integer be? So if x plus 1 is the second integer, then the first one is x. So x plus 1 equals 15, right? Well, how we can get rid of these parentheses. They're nonsense. I put them up there just to keep it neat for that little bit. We can just add all of this stuff through. It is x plus 1 equals 15. So what is x plus x? That is 2x plus 1 equals 15. And of course, we can just solve for x. Let's just do that just so we know we have it in our heads. We're going to start off with like the thing that's farther away, the thing that is the lowest priority, usually the lowest priority on your order of operations, right? So addition and subtraction. Oh, there, addition and subtraction. Okay. So let's go ahead and subtract 1 from this side. What happens when you subtract 1 from one side? Well, you must do it to the other side. So let's subtract 1 from this side. So 2x plus 1 equals 15. And that equals, so that will equal 2x equals 14. How do we get rid of the 2? The 2 is multiplying the x. So what's the opposite of multiplication? Division. So we must divide by 2. And you do that to both sides. And our end result is x equals 7. So x equals 7. That is the first integer in this problem. So then our second integer would be 8. And of course, 7 plus 8 equals 15. Boom. We've double checked all of our work and we are good to go. So I think that will be a good place to end this first lesson. I am going to keep doing this. I don't know. We'll see. We might do it every day. I might do it every other day. Whatever you guys want. If you guys want a live class, let's just say we'll start it at 9 a.m. I could do it every single day at 9 a.m. But I appreciate all of you that have hung out, that if you like this video, make sure you like it. Comment down below if you have any questions. If you need help with math, put it out there, right? If you need to hire a tutor, I do have my website. It is www.tutoru.net/mind. It is down in the description below. Otherwise, I hope you have a beautiful day. I appreciate you. And yeah, let's get you finished up with the GED, or let's just get you better with math. Anything, right? Have a good night. Or a good day. Good morning, good afternoon, good evening.